Hello everyone, this video will cover notes for section 2.2. Starting with number 1, is f a linear function? If so, give values for a and b so that f of x is equal to ax plus b. So we want to find which of these functions could be written in the form f of x equals ax plus b. Notice what's on the left side and what's on the right side of the equal sign. On the left, we just have the function. On the right, we have ax, and we have to find a value for a plus b and a value for b. So that means that we should have a number represented in front of the x and behind the x. All right, so when we look at the first function, our first function f of x equals 2x minus 7, we see that this function can be written in the form ax plus b, where the value of a would be 2 and the value of b, it's not positive, it's a minus sign there, so it would be negative 7. So we would go ahead and identify the first function as one that can be written in the form f of x equals ax plus b. Now let's look at the second function. We have 3/2 minus x squared. Right here we see our x term is to the second power. So this would not be representative of a function that could be written in the form ax plus b because we have our exponent. F of x equals 3/7 minus 4x plus 11 divided by 3x. Now, our x terms we see are both in the numerator and denominator of this fraction. It does not reduce to become a whole number. Therefore, because we see this fraction form, we would, again, not be able to identify this function as one that can be written in the form ax plus b. We should just have a single term times x plus or minus the b term. For the next function, f of x equals the square root of x, we see that our x is taken to, we're using the square root symbol. Therefore, this function, again, would not be able to be written in the form ax plus b. It's not given to us as a linear function. So the last function we see is f of x equals 17 minus, we have a fraction, but it's just that one fraction. We have some number 1/3 x. Now, this function can be written in the form ax plus b. We just have to reverse the order. We have to put the x term in front of the 17. So that would look like this. We would switch spots between the 17 and the minus 1/3. It would be written as negative 1/3 x and a positive 17, so plus 17. So our a term would be the number that's in front of x, negative 1/3, and our b term would be the number behind x, or 17. So we would identify the last function as one that can be written in the form ax plus b. Does the graph represent a linear function? Linear, remember we're looking for graphs that create a line. We see our first graph creates a line, so this would be a linear function. We see here that this graph does not create a linear function. So this one is not a line, and neither is our parabola. So the only graph that is a linear function is the graph that draws a line. Determine whether f could be a linear function. Now we have two rows of x coordinates, and then we have y coordinates. That f of x, remember, is the same thing as y. So really we have a bunch of ordered pairs. where our first column represents the order pair 0, -2. The second column 1, 1. The third column 2, 4. And then the fourth column 3, 11. 4, 16 for the last column. Now what we want to do is plot these points. To determine if this is a linear function, we need to see what will happen when we connect these points. Do we get a line or not? So let's plot the first point, 0, -2, 0, and then down to -2 on the y-axis. So 0, -2. 1, 1. So 1 on the x-axis up to 1 on the y-axis. Actually, it'll be between 0 and 2. So 1, 1. And then 2, 4. 2, 4. 3, 11. 3, and then up to 11. 4, 16. 4, and up to 16. So if we connect these points, we'll see that we do get a line. Therefore, this is, or it could be, a linear function. So we say yes, f could be a linear function. Why? Because the graph creates a line. Now we're asked to find the following: f of 3/7, g of 0.11754, and h of -1/3. So f of 3/7 we're going to substitute into our f function. And we'll get f of 3/7 equals 7 times 3/7 minus 2. Now when we simplify, the 7s will cancel. That leaves us with 3 minus 2, and 3 minus 2 is 1. So the value of the function when x is 3/7 will be 1. Now let's find g of 0.11754. So g of 0.11754 equals -15. It's just a constant function, -15. And now h of -1/3. We'll get h of -1/3 equals 4 minus -1/3. Now 4 minus -1/3, that's minus minus, that becomes plus 1/3. Now 4 plus 1/3 all right, now 4 plus 1/3 just gives us 4 and 1/3. So the value of the function when x is -1/3, we get 4 and 1/3. Now, is this a graph of a linear function? Y equals f of x. To determine if This is the graph of y equals fx, and we want to know if it's linear. Okay, we already see that it is. We have our line. And now we're trying to find the value of the function when x is 0, x is 6, and x is 2. To find the value of the function, or what happens on our graph when x is 0, we'll go up here on our x-axis to 0. And we want to determine where is our graph. When x is 0, what happens to our graph? Our graph is up here at 6. So this is the value of the function. It's 6 when x is 0. Now what happens to the function when x is 6? Here we're at 6. And what happens to our graph? Our graph is here too. Our graph is right at 0. So the value of that function when x is 6 is 0. When x is 2, here, our graph is at 4. So when x is 2, our graph is at 4. That's the value of our function at 2. All right, so here we have another linear graph. We want to find f of negative 2. When x is negative 2, where is our graph? Our graph is at 3. That's in between 2 and 4. Our graph is at 3. That's the value of the function. What happens when our x coordinate is 4? So when we're at 4, look at our graph. Our graph is right here at 3 again. You can kind of see a pattern here, no matter how big the number is. So even if x were a huge number like 5001, it doesn't matter how far out you go. Remember, this line continues. So our function never changes. It's going to be at 3 the entire time, no matter what the x coordinate is. This is what an example of a constant function would be. The y coordinate will always be 3. All right, let's look at the next example. We're going to sketch these graphs by hand, and we are going to create tables substituting 2 points. You only need 2 points to graph these lines. So we'll substitute 0 and 1 for each of the 3 functions. So we're substituting 0 and 1 for each function. 0 and 1 we're substituting as our x coordinates. All right, 0 and 1 for each of the 3 functions. So starting with the first function, when x is 0, we get 0 plus 5. So the value of that function would be 5 when x is 0. When x is 1, we get 1 plus 5. So the value of the function is 6 when x is 1. So the 2 ordered pairs, we're going to plot 0, 5. So 0, 1, 2, 3, 4, 5 on the y-axis will be here. And then 1, 6, 1, and then up to 6 will be here. And we connect those 2 points to make the graph. Now let's look at the second function. We're substituting 0 for x. We'll get negative 2 times 0, or 0, right? Negative 2 times 0. So the value of the function when x is 0, we get 0. When x is 1, we get negative 2 times 1, or negative 2. So the value of the function when x is 1 would be negative 2. Let's plot these points. 0, 0 will be right here at the origin. 1, negative 2, 1, and then down to negative 2, We want to connect these 2 points to create the graph. And now for the last one, 0, when we plug in any number, see how this is constant? I plug in any number, f of 0 will get 7, f of 1 would be 7. So 0, 7, 0, and then up to 7, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 0, 7, and then 1, 7. So over to 1 and up to 7. We'll see that those 2 points, they're side by side. So it creates a horizontal line through the y-axis at 7. Right here, we're at 7 on the y-axis. All right. If a certain fabric is priced at $2.89 per yard, express the cost of a purchase, C, so C represents the cost, as a function of the number of yards is purchased. So the number of yards that you purchase is called W. We're creating a function C. We're calling that function C that represents the price we pay, right, for a number of yards of fabric. Each yard that we purchase is $2.89. So to get the value of that function based on the number of yards W, so C of W, we would simply multiply the price per yard, 2.89, times the number of yards that we buy, which would be W. So here will be our function. C of W equals 2.89 W. Write a symbolic representation for a linear function that computes the following. We have the long distance phone bill in dollars for calling T minutes. So T represents minutes at 20 cents per minute. So the cost for each minute is 20 cents and a fixed fee of $4.95. And we're already given f of t as our function. So f as a function of time, remember t represents the time in minutes. And because we have a flat fee, that means we're going to pay that $4.95 no matter what. So 4.95 would be a cost that we have to pay, plus the amount per minute. You charge 20 cents per minute, so that will be plus 0.20. And for minutes, we're putting the letter T. So 0.20 T. This will be the function. And that concludes the notes for section 2.2. We'll end here.